Okay, programming crash course. We're going to cover some basic programming pieces, just kind of go over like the fundamental building blocks of what you can use to make a program. Overall, we're going to mostly focus on projects. I'm a learn by doing person. I figured that that is probably the best way to help this stuff actually stick and retain in someone's mind. The examples we're going to go over are all in JavaScript, but they all translate to most languages. I'm going by JavaScript to begin with because it's very flexible, it's pretty easy to learn. But if you didn't want to use JavaScript, some other common choices are Python or Java. JavaScript is mainly used for like websites. You can use it for writing backend services and APIs using Node, and mobile applications using React Native. Python is commonly used in the machine learning field, as well as a lot of math and data sciences. You can also create APIs and backend services in Python using something like Flask, Django, or FastAPI. Then Java is one of the more common academic languages. My college courses were done in Java. A lot of the current college courses are also done in Java. It is a strongly typed language, which means there's a little bit more to it to try to learn how to use it correctly, and it has more rules built into the language itself. So it'll stop you from doing things that maybe you don't want to do, but it can make the learning curve a little more steep. Java typically is also used for backend APIs or services using the Spring system, and you can create Android applications in Java, although more modern Android applications are being written using Kotlin, which is similar to Java and kind of just iterating on top of that language. So we're going to start with some common pieces of a language here. And the first one we want to start with is a comment. In most languages, if you do the 2 slashes, you can write text after it. And that tells the compiler or the interpreter to ignore those lines of code. You use them to leave notes and things about the program so you can understand what you're doing at that step or what kind of problem you're trying to solve. We're going to use them throughout this example to kind of denote what each of the pieces of code are doing. One of the most basic pieces of a programming language is a variable, and variables are just used to hold data. In JavaScript, the var keyword is used to denote a variable. So we can say var, and then we can give that variable a name. We called it greeting, and I can set it equal to some data. In this example, we're going to set it equal to the text hello. And then I can use console.log to output things so I can see it in the console. So I can say console.log greeting, and it will output hello in the log. In more modern JavaScript, they got away from var and they use let and const. So the main difference to remember is that a let can be changed and a const cannot. I can say let name equals junior dev, I can log that, it'll be junior dev. And since it's a let, we can then change it to be a senior dev, and I can log it and see that it'll be senior dev. If I used a const instead, I can set the variable just like normal, but if I try to change it, so if I get rid of this comment here, it's going to say, hey, we can't change that because it's a constant. Constants are read-only. Put that back. And then at a high level, there's a couple of different key types of variables. So looking down here, we can see different types of data. Up above, we used a text, which is called a string in most programming languages. We have integers, which are whole numbers. We can have a fraction, so you can have a decimal, double, float. In a more strongly typed language, doubles and floats are different, and they have different levels of accuracy. As far as JavaScript is concerned, it's just a fractional number. And then you can have a Boolean, which is used just to hold a true or false. One of the main things that programs are used for is to do some level of math. So we're going to go kind of top down here and look at some different type of math expressions that we can evaluate in JavaScript. The first one is Boolean logic, so just determining if something is true or false, and we can use those in a later section when we go over how to control the flow of code. And then just as a note here, we can use this backtick and build what's called a string template, and that lets us run little snippets of code inside of a string and see the whole output put together. The double pipes is used to denote an OR, and that means if either one of these things is true, the whole expression evaluates to true. And there can be any number of these. You can have true or false or false or false. As long as one of them is true, the whole thing says true. And then on the flip side, we have this double ampersand, which means and that means that they all must be true to evaluate to true. So if you have 10 trues and 1 false, and they're all ANDed together, then the overall expression evaluates to false. There's also some basic math built in, so you can add numbers, you can subtract numbers, multiply, divide, and then you can do what is called a modulus operator. And the modulus actually gives you the remainder from the division. As an example of how you might want to use the modulus operator, say that we need to pack a bunch of boxes of cookies. each box can hold 15 cookies and they have to be completely filled. To learn how many boxes we need to figure out how many times 15 goes into your total number of cookies here, which is a lot of cookies. We can do that inside of this little JavaScript section here. So we can take the number of cookies and we can divide it by how many cookies per box, and then use math.floor as a built-in math function to round that number down. It'll tell us how many full boxes of cookies we can create. And then if you wanted to know how many cookies you would have left over, you can use the modulus operator to tell you how many cookies will be left over from that. You can also compare things in JavaScript. JavaScript is very specific with the double versus the triple equals. Double equals is what's called a fuzzy match. So it thinks if the two values seem the same, but maybe not are exactly the same. So in this example, the number 123 and the string 123 with the fuzzy match evaluates to true. But the number 123 and the string 123 with the triple equals, which is a very specific comparison, evaluates to false. And then the exclamation point is used to denote not equals. So if we check if the string 123 is not equal to the number 123, that would also evaluate to true. We can also do greater than and less than, and then also less than and equal to. And if I run this, we can see the output of these. You can say true or false is true, true and false is false. You can see the math output here. 12 modulus 5 is 2, because 5 goes into 10, and then 12 minus 10 is 2, and that's your remainder. So going back to the cookie problem, if we have this outrageous number of cookies and we have to pack them all into a box, this is how many boxes we would need. And there would be 12 cookies left over. It's a bit of an arbitrary example, but that is one way that you can use the modulus operator. Then if we go through and check our comparisons, double equals gives those two things as true, triple equals makes them false, and then the not equals check says that they are in fact not equal. Most programming languages have the concept of a collection. Collections are just ways to store data together. A very common type of collection is a list or an array. In JavaScript, they're treated as essentially the same. In most languages, an array has a fixed size, whereas a list is flexible and you can kind of add things to it as much as you need to. And to create one of these things in JavaScript, we use these brackets. So I can make a constant, which is a list of dogs, and I can add Peter and Rain to the list of dogs here. If I were to output that, it would come out like this in the console, where you can see the list of the two elements. And then if we get a new dog, you can use the push operator here, and you can add something to that list. And then if you were to output dogs again, you would see that Helen was added to the end of the dog list here. So in most languages, arrays and lists start at index 0, which means that the first element is the 0th index in the array. So if we looked at dogs index 0, that would be our first one here, which is Peter. Dogs index 2, if we count 0, 1, 2, that gives us Helen. And then if we try to access dogs index 3, which would be the one after Helen, in JavaScript it returns undefined because there is nothing at that index. In some more strongly typed languages, such as Java, if you try to access this, it would throw an exception and crash the program. And it would give you an index out of bounds exception to let you know that you tried to access an index that no longer exists in that list. And then we can check to see if something is in our list of things by using this includes method here. So you can say dogs.includes and then pass it something that you want to check. And because Helen is in the list, that will return true. Another very common data structure is a map, and maps are used to hold key value pairs. We can make a map called favorites, and then we can say new map, which is how you make a new one. Favorites uses this set method that lets us put data into it. So it's going to set my favorite color to blue, my favorite animal to dog, and then if I log that, it comes out in this format here. So you can say color is matched to blue and animal is matched to dog. I can use the get method here to return something out of that map. I say get animal, it looks at animal and goes, oh hey, that's a dog, and it returns dog. In JavaScript, if you try to get something that is not in the map, it gives you an undefined value. So if I try to get food, because we haven't set my favorite food, it returns undefined. The keys are the first thing that you pass in here. So that's all of the things that you have set. The values are the values for those keys. So that is the second piece here. That's what each of those keys maps to. If you create a map and then you want only the keys or only the values, you can look at just that piece of the data. In this example, everything was a string and a string mapping one-to-one. You can also mix your types. It can make it a little tricky to figure out what your expected inputs and outputs are for the map, but JavaScript does support it. So you can use a string and then a number to map things together. You can have a string and then a list of dogs that we made up above here, or you can use, say, a number for your key, and then you can have a string for the value. And so if I do a get on dogs, dogs is a list, and it would output that list in the console there. Two other things that come up quite frequently are stacks and queues, and they kind of function as the opposite of each other. With a stack, you can think of it like stacking things up, like a stack of plates as an example. The last thing you add to the stack is the first one that comes out when you go to reach for one. To give us the last one added, we can use this pop method, and that will give us the last one that came off. So we add 2, and now it's like 2. We add the 5, it's now 2, 5. And then we pop, and we pop the 5 off. That gets stored in our variable here, and we are left with just a 2. And then queues are sort of the opposite. So for a queue, the first thing that you add is the first one that comes out. You can think of it like you're setting in line, like waiting to buy tickets at a theater or order your food at a restaurant, something of that nature. Just like before, we can add the 2, we can add the 5, which gives us a 2 and a 5 here. We use shift instead of pop, and shift actually pulls the first value added out of there. So it's going to pull out the 2, so now j is equal to 2. Now that we know the different bits of data that we can have, we need to get a way to sort of collect those things together and make them represent something in our program. And that's where objects come into play. Objects are used to represent a specific type of data. You usually refer to entities inside of the program as objects. In JavaScript specifically, you can kind of think of it as like a fancy map. For the map example, like name would be our key, Helen would be our value, type would be a key, dog would be a value. So this lets us come through and build all these things in like one place instead of doing it line by line inside of the map. So I can have a constant of Helen. Helen can have a name, she can have a type, a breed, an age, a weight, whatever else I would want to add inside of here. So if I log Helen, it comes out like this in the log, and it kind of gives each of the key value pairs separately. And then if I wanted to access something specific on her, I can say helen.breed, and it will return the breed that we set here. And then if I wanted to iterate over Helen and see, what kind of things does she have stored, we can use a for in loop, and that's how we iterate over objects. I can say for, which just tells me I'm going to loop. I can define my variable that I want to use for each piece of the loop. It's going to be key, and then Helen is the object that we're going over top of. Then I can output the key, and then that key indexed into Helen, and it will one by one go through the list. It'll get name, and it'll go Helen's name, and it'll output that. It'll then get type, breed, and so on. So I'm going to make a couple other ones here. We also have Peter, and we have Rain, and then I can take all 3 of these, and I can add them to a list. Not only can you use them individually, but you can also start to combine the things that we've gone over before and add items to lists, and then use that list in other places. To be able to use it somewhere else, we're going to say module.exports, and this is how we tell JavaScript that we want these things to be available in other files inside of the program. We want to see the output of what this for loop looks like. I'm going to come up here and run this program, and I can see down here that at the top I output Helen. This is what Helen looks like in log. Output helen.breed. This is her breed. Then we get into the for loop. It says for each key in Helen, output key, and then that key name and value, and the value for that key inside of the Helen object. So I can see I have key name, value Helen, type of dog, breed is Border Collie, age is 2, and weight is 45.7. The next thing we're going to go over is control flow, which controls the flow of the code. Not a super good definition, and it should make more sense as we get into some of the examples. but at a high level, it gives us a way to repeat pieces of the code without having to write them out multiple times. At the top of this file, you can see that we're going to use this require keyword to import data from a different file. So this object is the file name that we used here, and here we exported them. So we exported Helen, Rain, Peter, and the pets list. And now with this file, we can require it, store it in the variable called objects, and then we can access that later. The first example is a while loop, and a while loop will run as long as this condition inside of here is true. So in this example, we start with a variable called count, and it's equal to 0. And then while our count is less than 4, it's going to output count into the log, and it's going to add 1 to it. This count equals count plus 1 is sort of the basic way to just increment by 1. You can also write that as count plus equals 1, or even count plus plus. All of those will just add 1 to the counter every time the loop executes. So it's going to start at 0, it's going to say 0 is less than 4, so it will output 0, and it'll add 1 to it. Now count is equal to 1, and it comes back up to the start. It's going to say 1 less than 4, so on and so forth, until it gets to 4. So when count is equal to 4, it's going to come back up and say, oh, 4 is not less than 4, and then it'll just continue. It will break out of that loop. Probably the most common form of this iteration is a for loop, typically used to iterate over like arrays, lists, other types of collections. So your basic for loop has this structure. You define a variable in the beginning. Most of the time that variable is called I. I is short for iterator, and that just seems to be where most people go with their like naming conventions for these variables. So you start at 0, then you say this is what you want to test for. So as long as I is less than our pets list dot length, and then this is what happens every time the loop completes. So we want to run the loop one time, and then we want to add 1 to I, so it goes to the next element. If you wanted to, say, skip every other element, you can say I plus equals 2, and it would just do every other element in the array. And then we're just going to, for now, output it to the log, and you can see that it will output the entire list one by one. A more modern way of writing this is the for of loop. Similar to the for in that we used for the object, you can use a for of to go over a list. So you still have for, you still define your variable. So we say pet is going to be our variable, and then we put of, and then whatever list or collection we want to sort of iterate over top of. In this instance, we're iterating over the pets list, and then we're just logging it out, same as always. There are instances where you want to pass a function in to do the same thing. This is a little more advanced and can give some weird behavior if you're not quite sure how you want to use it. So we'll go over this in more in depth when it comes time to actually use it. So you can write the function either with the function keyword, and then you can pass in pet, which is your variable that you're going to use, or you can shorthand that in Node and use this fat arrow function. And this arrow just takes place of this function keyword. All 4 of these for loops will function exactly the same. And again, this for of here is probably going to be the one that we use most commonly. Another very common form of control flow is an if statement, and an if statement is used to make decisions based off true or false. You use the if keyword, and then what you want to check goes inside of the parentheses. In this instance, we want to see if Helen's age is greater than Peter's age. If it's true, it runs what's inside of this first set of brackets. So if Helen is older than Pete, it will output Helen is older than Pete. And then the else is what gets ran if this condition evaluates to false, which in this case is the one that would print because Peter's age is higher, and it will print Peter is older than Helen. The if statement has a shorthand called a ternary operator, and the sort of the breakdown of how this looks is you write what you want to test, and then a question mark, and if your test statement is true, it returns the next piece, and then if it's false, it returns what's after that colon. In this example, I have a variable called has 7 dogs, and I want to check if my pets list length is higher or equal to 7. If that's true, then has 7 dogs will be assigned the value I have at least 7 dogs, and if it is false, it will be assigned the value I have less than 7 dogs. So we can run this, we'll see what all of our outputs look like here. Scroll back up to the top, we have our 0, 1, 2, 3 that we have here. This require, since we require that object, it's also outputting everything from this file. So that's what happens when you put a bunch of logs and imported files. If we get down to this, we are going to one by one start outputting our pets. So you can see that it outputs Helen, and then it outputs Peter, and then it outputs Rain. And then again for the extra loops, we go Helen, Pete, Rain, Helen, Pete, Rain. We scroll down to some of the more interesting pieces here. We're going to check and see if Helen's age is greater than Peter's. It's not, so it prints Peter is older than Helen, and that's what comes out here. And then for the ternary operator, our pet's length is less than 7, so it prints out I have less than 7 dogs. Similar to the way that we use control flow to repeat pieces of a program, functions are a way that we can take some logic that we want to do and sort of encapsulate it in a way that we can reuse it later. Again, to start this, we're going to pull our objects in from the objects file. That way we can just access our dogs list and all of that sort of stuff. And then we're going to write a function. So we're going to use this function keyword. We're going to give it a name, call it who is older, and then the bits of data that we would pass to it. So in this example, we're going to pass 2 dog objects. So we call them dog1 and dog2. And then we're going to determine which dog is older. So if dog1 age is greater than dog2 age, we're going to say dog1 name is older than dog2 name. And then we can chain these if statements together. So similar to before we had if and else, this has an else if, and this means that it starts at the top and kind of goes down until it hits the statement that is true. So else if dog2 age is greater than dog1 age, then it will output dog2's name is older than dog1 name. And then this else at the end is the block that gets ran if none of the above statements evaluate to true. And in that case, it will say that they are the same age. And then to call this function, we just type who is older, which is our function name, and then we pass in what's going to be dog1 and dog2. So for this example, we have objects.helen and then objects.peter, and then we can call it again with Peter and Rain, and then another time with Helen and Rain, and we can call this as many times as we want to. This is good if we just want the output to happen instead of the function, but sometimes you want the function to do some calculations and then return the data back to you, so you can then use that data somewhere else. So in this example, we have a function called oldestDog that takes a list of dogs. So to start with, we're going to make an oldestDog variable, and then we're going to set it to undefined, because currently we don't know who is the oldest dog, and undefined is like a blank placeholder in JavaScript. And then we're going to use our for_of loop, and we're going to iterate over the dogs list that was passed in. If our oldest dog is undefined, or our current dog's age is greater than our oldest dog's age, we're going to take our oldest dog variable and set it equal to the current dog variable. So what this means is the first time through, oldest dog is undefined, so we start with saying, okay, the oldest dog is just the first one in the list. And then the second time through, oldest dog has a value, and it will actually start to do this age comparison. And then after it's looped through all of the dogs, we're going to return whatever our oldest dog was. So this return means that wherever this function was called, take this value and give it back to them. So if we come down here, we say constant myoldestDog equals oldestDog, and then we pass it our list of pets. So this function will go through, it'll loop over all of the list of pets and return back the oldest dog, which in this case is Peter. So we come up and we run this, we can look at the who is older. It says Peter is older than Helen, older than Rain, and Rain is older than Helen. And then this my oldest dog, it found Peter, and then when we just pass the Peter object to the console, it prints out his whole object here. The last thing I want to go over before we get into a couple of examples of how to use all the things we've been talking about are classes. So before, when we made objects, we defined each of them separately, and it was kind of up to us to make sure like they all had a name, they all had a type, so on and so forth. So with a class, you can use it as like a template for your objects, and you can define things that all of them will share. So we're going to define a class. We use a class keyword. We're going to call it dog. And then constructor is what is used to make new ones. So we can say that we have a constructor and it takes a name, a breed, an age, and a weight. And then inside of a class, you can use the this keyword to set things on that class specifically. So like on that instance of the object. So they're going to pass these fields in, and then we're going to store them on our object to set name equal to the past name, our breed equal to the past breed. You can also define functions on your object. So similar to defining functions separately out here, if we wanted all dogs to have this who is older function to be part of the class, we could just copy all of this and then pass it in. So in this example, we have a function called isSameBreedAs, and then they're going to pass in another dog. And all we want to check is if this breed is equal to the other dog's breed, and then I'll return true or false depending on if they're the same. We also have a describe function, which is just a prettier way to output the object to the log. So previously, it was really just like a name of key value pairs, like a big list of them. And now we can call describe instead, and it'll output a much nicer looking, sort of like a sentence, to describe something about this object. So if we run this, you can see down here we made a new constant called scout. We use this new keyword to mean that we're going to make an instance of this class. It is of type dog, which matches the class name up here. And we pass in a name, a breed, an age, and a weight. And then if we output scout.describe, we get this nice sentence output here instead of the weird output that we had beforehand. We're going to make another constant called moose. Moose is also a dog with the name of moose, breed of lab, age of 1, and a weight. And then we can check to see moose.isSameBreedAs. So that means for this moose instance of the class, call the isSameBreedAs function that we have defined here. And then we can pass in scout. And in this example, scout would be the other dog. So it's going to say if moose.breed is equal to scout.breed. And in this instance, they are both labs, so that comes back as true. Okay, so now we're going to use what we've learned and work through a couple of like programming interview question examples, just to sort of show how all of the different pieces that we've gone over come together to solve a couple of common problems. These problems are a little arbitrary, but they're used to sort of demonstrate your knowledge of the language and your ability to solve problems, and it's not necessarily solving a real-world problem. To start with, we're going to reverse a string. Most languages have a function built in where you can just call string.reverse and it'll do this for you. But if we wanted to do it manually, we can define a function, we can call it reverse string, and it's going to take some input, which will be our text. The way that we're going to do this is we're going to make a stack. And then we're going to take every letter that was in our input and we're going to add it to that stack. And then because a stack will take the last thing added and pull it off first, this means that we can come through and then while our stack length is greater than 0, so while there's something left in it, we can take our output variable, which is just an empty string defined here, and then we can just pop each of those letters off. So if we think about this with hello, we're going to push each of these letters on. So we'll push the H, we'll push the E, we'll push the L, and the O. And then when we pop, it's going to come off in the opposite order. So it'll pop the O, the L, the E, and the H. So if we run this, we can see all of these reversed. This example is a little bit more of an involved problem. This is a pyramid word example. What that means is that a string is a pyramid word if you can take all of the letters and arrange them so that how many times they occur in the word builds a pyramid with the numbers. A better way to sort of conceptualize what we're going for is to look at some examples. The word mom is a pyramid word because the O occurs 1 time and the M occurs 2 times. Banana is also a pyramid word because the B occurs once, the N occurs twice, and the A occurs 3 times. Bananas is not a pyramid word because the B and the S both occur once. So we have to count all of our letters, and the counts have to start at 1 and then go up 1 until we reach the end. So if we count them all and it goes like 1, 2, 4, that is not a pyramid word. It has to go 1, 2, 3, 4. To come through and test this, we have a function again. We're going to call it isPyramid, and it's going to take a word. To keep track of our counts, we're going to use a map, because a map is a very easy way to do like key value, and it's usually the go-to for counting things like this. What we're going to do to start is we're going to go over each character and input, and then we're going to say our count, which is how many times this letter has occurred, equals the character count from our map for this character. We know that if the character is not in the map yet, we get undefined. So that means that we should just say, okay, it has a count of 1, and then we're going to store that back into the map. Otherwise, we're going to get a number back out of there and go, okay, well, we have this one already. Let's just increase the count by 1, and then we're going to store the new value inside of the map. So when we get through this for loop, we should have an output of all of the keys as the character and the values as the frequency. Next, we need to check and make sure that each of the frequencies starts at 1 and continues to go up from there. So the easiest way to do that is to take all of the values, which is all of our counts, we're going to convert them to an array. So we say array from, and then pass it the character count values, and then we're going to sort it. So that means in theory it should start at 1 and then go up by 1 for every element. So 1, 2, 3, 4, so on and so forth. So now that that's done, we can do a for loop over it, and we can start at 0, and we can go all the way up to however long our counts are and increase I by 1 every time. So if I starts at 0 and we know that the first element should be 1, that means we have to add 1 to I every time for our check. So we're going to say if counts and then whatever index we're at does not equal our index plus 1, that means that we missed a number and that we should return a false. And then if we make it all the way through this, we're going to return true. Having this return false here means that if they hit it, they'll return false immediately and the rest of the program does not execute. So if we run this, we can see that we're testing mom, and then our map is M has an occurrence of 2, O has an occurrence of 1, and then mom is true. And then banana breaks down into B1, A3, and 2. Banana is true. And then testing bananas with an S, we have B is 1, A is 3, N is 2, S is 1, which means that it comes out false. The last example we're going to look at is actually a question I took from a Google interview that I found on YouTube. I thought it was a super good example. And the question itself seems very basic, but once you get into it, you can find that there are multiple ways to solve it, and some of them are better than others, which is true for a lot of programming problems that we get into. Oftentimes, there are many ways to sort of solve the problem that you're looking at, and they have pros and cons depending on the approach that you take. What we're trying to check is for a list of inputs, check and see if any two of the numbers can be added together to give the desired output. So as an example, if we get the list of 1, 2, 4, and 7, we want to see if any of them can be added together to equal 8. Well, looking at it, we can tell that 7 and 1 can be added to be 8. So we know that we should be returning true for this. And we have a bigger example, which can take a little bit more time to get into. And where this comes into play is this input might be 1,000 numbers. You don't want to, by hand, go through and check all 1,000 numbers to see if any of them add together to give you 14. So we're going to write a program to do that instead. So I've written this program twice to show you the pros and cons of two different approaches. The first one we're going to call has some basic, and the second one is has some advanced, and we'll go into sort of what's happening with both of those. The basic one is the most direct approach. This is probably the thing that comes to your mind first when we're looking to do something like this. We're essentially just going to do two loops. So we're going to start at the beginning, and then we're going to take that first number and we're going to compare it to all of the other numbers. And then once we get done with that, we're going to start at this number and compare it to all the other numbers. And then come back and start at this number and compare it to all the other numbers. So it'll get you there, but it's a lot of comparisons. And at a high level, what you'll realize is that once you start doing for loops inside of each other, there is probably a better way to do it. But we'll go over the two examples, and then we'll look and see what the outputs look like for both. We're going to look over the list, so we're going to start at I being 0, and then we're going to go over the entire list and add 1 to it every time to walk down the list. And then inside of that, we're going to call it j. J is just usually the next one that people use after I. We're going to start at whatever our I is plus 1, and then we're going to go through the rest of the loop there and add 1 to j every time. And then just so we can see what's happening, I'm going to output I and output j to the log. And then all we really want to see is if our inputs at index I plus our input at index j add together to equal the sum. And if they do, we're going to return true. And if they don't, we're going to return false. And if we come down to the more advanced version, we are trying to avoid doing the 2 loops. What we're going to do instead is we know for each of the numbers that the number that we're looking for is whatever we can add to it to give us the output. So we're going to make a constant called looking for, which is a new set. And a set is just like a list that doesn't contain duplicates. So if you're not concerned about duplicates, usually a set is a better thing to use. And then we are going to use a for loop again. So for I and each of the inputs, we're going to look at whatever our current number is, and then we're going to look at the looking for variable and see if the number that we currently have is a number that we're looking for. And if it is, that means we can add it to a previous number to get the output that we're looking for. We have our looking for variable. We have this built-in has method, and that lets us know if our looking for set contains the number that we currently have. And if it does, we can just return true, because we know that we've previously seen a number we can add to our current one to get the output that we're after. If it doesn't, we are going to take the sum, which is what we're looking for. We're going to subtract our current number, and that will tell us what number we should be looking for in the list to be able to add together to get the sum. So we're going to store that, and then we're going to come back to the loop and we're going to continue to go. If we make it through the entire list and we don't find any 2 numbers we can add together for the sum, we're going to return false. So if we run this, we can kind of walk through the outputs here and take a look at what's going on. And it'll become apparent based off the log why one of these methods work better than the other. So from the first one, you can see that we're walking through our basic inputs and outputs here. So we have 1 and 4, 1 and 2, 1 and 7. It hits 1 and 7 and goes, oh hey, I can add those 2 to get 8, and it returns true. And then for the advanced one, we start with 1. Our looking for is empty. So it's going to take 8, it's going to subtract the 1, and it's going to add that 7. It gets 4. It says, okay, I'm looking for a 7 and a 4. It gets the 7. Our looking for contains a 7, and it returns true. So for the basic input, our first one here actually got there faster than the second one, based off the log output. But then if the input gets a little bit bigger, we can see, like for this example, if we scroll down, we have a lot of comparisons happening in that nested for loop to try to find the value that we're looking for. Whereas with the more advanced one, where we're not doing the nested for loops, we can find it much faster. So when you're trying to design your program and determine, what solution is the best, you always want to assume the largest input possible, because that's sort of your worst case scenario. In this example, if the 2 numbers that we added together to get the sum were the last 2 numbers in the list, then the first loop would have to make a lot of iterations to find those last 2 numbers, whereas the second one, no matter how many inputs we have, it's just going to have to go through the list one time to find the number that it's looking for.